Hello everyone, welcome to the 8085 programming series. Today we will do a program. So here we have write a program to multiply numbers 0, 8 and 06. So we have to multiply the two numbers 0, 8 and 06. So in 8085 there is no multiplication instruction. We don't have any multiplication instruction. So how to multiply? So we can use a trick by we can multiply two numbers by using a trick called as multiplication using repeated addition. So here if we want to multiply 08 with 06, then we can actually add 08 6 times. Okay, so suppose if we go on adding 8 6 times, we get the required result. So this is the trick we will be using in this particular multiplication program. So very first instruction, as we can see, it is XOR A. Now what does XOR A do? XOR A, it clears the contents of register A. So suppose register A, by default it may happen that it may contain some data. So we want to clear register A. So one of the trick is using XOR A. XORing A with itself will clear the contents of A. Then the next instruction, we load the larger number of the two in register B, and so with this instruction MVIB, 08 will be stored in register B, and the next instruction MVIC, the smaller number will be stored in register C. Now this is the part which is doing the repeated addition. So with XOR A will become 0. With MVIB 08, B will contain 08. With MVIC 06, C will contain 06. Now with add B, we have A equal to A plus B. Okay, so A is 0, so 0 plus 8 is 8. Okay. And then with DCRC, C will become 05. And this instruction J and Z, what does it say? Is C 0? If C is not 0, then jump to add B. So this J and Z is checking whether this contents of C has become 0 or not. If it is not 0, it will jump to this add B. Now with add B, now A has become 08. Okay, so now add B means A equal to A plus B. So again 8 plus 8. Then again we decrement C. Now because C will become 4. Okay, then it will again add. So this time the A will be added, this 8 will be added 3 times, and this will continue, and this will continue until C becomes 0. And by the time C becomes 0, this number 08 has been added 6 times, and the result we get in register A. So this is how this program is executed. Now let us this is how we do the program. Now let us execute it on Jubin's 8085. So now I will just use this Jubin's 808, just turn it on, this start this application Jubin's 8085 simulator. So we get this interface now. Now here there are two ways of doing the program. One is we can go into the kit mode. Okay, that is also okay. We can just click here and just type the instruction as I've shown in the previous video. Now there is one more way of doing this program. So before typing the instruction, because if we type the instruction, it by default it will start from 0000. So the very first thing is we will set the memory location. So go in settings, and we can type the set the memory location range. Okay, so we type this, you can see we can just make it as 8000. It would be when you turn it on, maybe it will be 0000. So if it is not 000, type 8000 here. Okay, and then we come to this register mode, and now here what we do, we type the instruction. Okay, instead of entering the memory location, we just type the mnemonics. This is one of the advantage in this case. So the very first mnemonic, if you remember, it was XOR A. Okay, then the next instruction was MVI. Okay, MVIB. Okay, and it was 08H. Then we have MVIB, have to take actually MVI space B, and then 08H, and then next instruction is MVIC. Okay, and it is 06H, and then here we have add B, then DCRC, and then we have J and Z. Now J and Z, we have to specify a label. We can give any name. I will just type UP up. Okay, and then halt HLT. Now we have to specify where it has to jump, so we have to use this label up where we have to specify the jump. So I will use it at this, because add B where we have to jump, so add B and a colon. Okay, so this is the code. Okay, now after typing this we have to assemble. You can see this assemble. Okay, now when we assemble we get this is what we have, 8000 XR A, and all the instructions what we have seen in the previous slide. This is what we get. Now here there are two ways of doing the program: run all at once or run step by step. Now ensure that this is 8000, because our starting memory location is 8000. By default generally it would be 0000, so you must type here 8000. Okay, then let us go by step mode. Okay, so I'll just type step by step. If you run at all at a time, then we'll directly get the result, but let us see by step. Okay, now after we click this, now we go forward. Okay, so with the first instruction XR AA, we get A has 0000. Okay, now we move further. Okay, and you can see 0 flag is set because A is 0. Okay, and parity is also 1. Here flag contents are also shown. With the next MVI B, we see B becomes 08. Okay, with the next instruction MVI C 06, so C contains 06. Now with add B, okay, add B means A equal to A plus B, so 0 A was 0, 0 plus 8 is, of course, this is 08. Okay, then with DCRC, as we can see, C becomes 05 and 0 flag is reset. Okay, then we come to the next instruction JNZ up. Now because C is not 0, you can see 0 flag is still reset, it is not set, and we are telling jump if not 0. So we'll jump. Okay, you can see it has jumped up. Okay, the one which is highlighted is executed. Now again add B. Now 8 plus 8 is 16 in decimal, but here we have 10 because this is hexadecimal, so 10 is 16, so 8 plus it will be 10, not 16. Then DCRC, okay, you can see just what we are getting. It is with DCRC it will become 4, it's still not 0. Okay, then again jump up 0, add B, so we have this 10 plus 8 is 18. Okay, then again DCRC it is 3, then jump JNZ up, so this will continue. Okay, I'm just going step by step. Okay, and this is the maybe the last one. Okay, so we get the answer is 30, and you can see now with DCRC C has become 0. Okay, and 0 flag is set. You can see 0 flag is set, so now it won't jump up because 0 is flag is set. It will come out and the program gets completed. So the answer is we get this answer is 30. Okay, because 8 6 are 48. It is of course 8 6 are 48, but it is in decimal, but in hexadecimal we get this answer. So that's all for this particular session. Thanks for watching.